Okay, so today we are working on 15.3, which is constructing exponential functions. So if you take a look up here, guys, before we start working on exponential functions, we got to make sure we know what an exponential function is. So an exponential function is when your number is being multiplied by a ratio, which is going to create a curved line. So everybody write exponential is going to create, and I'm going to say create a curved result. I'm going to say a result because of what we're going to talk about next. All right, so when I say a curved result, there are two different types of results that we can have. One is discrete and one is continuous. So who remembers, by raising your hand, please, what discrete means? Anybody remember? Go ahead.
Dots.
Say again. Dots. Yep. So I'm going to write dots down. Okay? And then how do I know to represent it by dots? What is it that's given to me?
Doesn't that mean that it's just
No, not for...
Is it an X value?
Yeah, the X is the domain. I'm going to call it the domain is given to you. You got it. Nice job. The domain is given. So then obviously continuous means that the graph goes,
It's connected.
yes, is connected. You got it. So we're going to write that it's connected, and then the domain is not given. Now guys, I know, I'm going to write this down, domain not given. Instead of writing down, we're going to use the default of -2, -4, -6, or -2, 4, or whatever. The reason I'm not going to write that down is because in this unit and the next one, we're not necessarily going to use those -2, -1, 0, 1, and 2. Okay? We're going to choose them strategically. All right, so when we're talking about exponential, we're expecting a curved result. We have two different types, dots and connected. Okay, so now what is an exponential formula? So this is what an exponential formula is. It's very similar to an explicit. So write this down, f of x equals a times b raised to the exponent of x. I'm going to tell you what these letters represent.
I bet your B is the Y intercept.
Okay, so if you look right here, actually the b is the first one I'm going to talk about, and that's actually your ratio. Now, I want to keep going because we've done this last couple days, is how do we find the ratio? We take our second y value divided by our first. Remember, it doesn't necessarily have to be the second. It's the one on the right divided by the one that's previous to it. So write that down. Is I'm going to write the second y value just because it's easier to write, divided by the first y value. So that's the easiest part. So if you know what your ratio is, or if you know how to find your ratio, you're in good shape. Okay, so right here, the A, for our purposes today, and we'll get a little bit more into this as we learn a little bit more about exponential, is it's going to be your multiplier. So write that down. And really, that's all you need to know for today, is that it is your multiplier. The X represents your exponent, obviously, but it is the result of the n-1 in your explicit formula. Okay? So it is the result of the n-1 in your explicit formula. All right? So write that down. Result of, and I'll explain that a little bit more too, the n-1. Okay, so I want to review real quick before we get going on this. So if I have, remember from the other day, a of 3 equals 76. We know that 3 would represent the x value. Can you just write this down? And 76 would represent the y value. Do you guys remember that? Give me a little, yeah, I sort of remember that. Okay? So 3 would go in the x spot. And where would 76 go?
Y.
Which is f of x. Because doesn't f of x equal y? So you might want to write that down. That represents your y value. Does that make sense, guys? That's the result of what you have. That is the result. All right, so this first part is pretty easy because we're going to actually just plug it into our calculator. And here's the first problem. So to find the y value, or the f of x, we're going to times, or equals, we're going to times it by 1/2, which is our multiplier, times by our ratio, which is 4, to the exponent of x. So this is why I had you guys working on doing exponential functions, plugging them into your calculator correctly. All right, so right here we're doing -2 negative 1, 0, 1, and 2. So you're going to do this, and you're not going to get whole answers, numbers. They're not going to be pretty, okay? So you're going to do 0.5 or 1/2, I don't care what you do, 1/2 times 4, and then caret negative 2. And when you get that result, it's going to be a small number, which is, I'm going over here to grab it real quick to make sure you guys have the right answers for these. So if you take a look, yep, you're going to write that down. So what is the result? It is 0.03125. So write that down, 0.03125, and that's correct. Because I'm going to show you what's happening here with a exponential function. Okay, so now we're going to do negative 1. So if you plug it all the way into your calculator, now all you have to do is go up and over, replace that negative 2 with negative 1, get a result, and write it down. Your answer should be 0.125. Yep, 0.125, which is correct. All right, so then we're going to plug in 0, which is what? What's that answer?
1/2.
Yep, 0.5 or 1/2. So I'm going to put 0.5 because I'm going to keep my decimals. Then you're going to plug in 1, and you get 2. And then you're going to plug in 2, and you get 8. Now watch what happens when we try to graph this. I want you to be really careful. So you go over to negative 2, and you go up 0.03125. You have to estimate it. You can't tell exactly where it is, but I know it's just right above that line. Just right there. Then go to negative 1. And now, do you understand that 0.125 is bigger than this number right here?
Yes, because
So-
there's not the 0.
So it's going to be a little bit above that, just a titch. So you can't really show it too much, but try to make it just a little bit above.
I did it.
And then 0 is up 0.5, so that's in the half spot right there. And then go over to 1 and go up 2, put a dot right there. And go over to 2 and go up to 8.
Lift off.
And put a dot right there. And what I want to show you is that number 1, we are not connecting our dots because the domain was given to you. So don't connect your dots. And I'm going to show you something. I'm going to connect my dots because I want to show you what the result actually happens. So if you look right here, guys, at this yellow mark that I'm putting in here, this is called an exponential function. What I want you to understand is this fine line right here, it actually will sit right here on top of the x-axis, and it won't actually ever hit the x-axis. It won't go below the x-axis. That's an exponential function right there. So it starts out really small, and then it gets bigger. Do you guys understand that? So an exponential function never goes below the x-axis if it starts above. If it starts below the x-axis, it will go down and never go above. Okay? That's what an exponential function looks like. Yes, you have to estimate those answers right there, but you need to form a curved result. Don't connect the dots unless they're given to you, okay? All right, flip it over to the other side. One more example. I want you guys to do this example real quick, and then we'll write these answers in. So the problem is 4 times 3/2 raised to the exponent of x, and that's f of x. Write your table down, -3, -2, -1, 0, 1, and 2. All right, I'll give you about 30 seconds to do that. Because remember, all you got to do is go back up and over. Okay, and plug them in. Okay, so as you guys are doing it as well, I'm going to fill them in so you guys can check them with me. Remember, the first couple ones, yeah, they're not nice, pretty answers, okay? They are not. So I have the answer for number -3 is 1 and 5 over 27. 2, 1 and 7/9. This one is 2 and 2/3. And 0,4. And 1,6 and 2,9. So go ahead and graph that, starting at -3, and it's an estimation. So it is up 1 and 5/29, which is actually just above the 1. And number -2 is going to be a little bit taller, or a little bit higher than that, I should say. And -1 is 2 2/3, so 2 2/3 is about right there. And 0, 4 now gets easier. 1, 6 and 2, 9, which is off our graph. So are we connecting these dots? The answer is no. Don't connect them. I'm showing you with my highlighter. Do you see the exponential function?
Because it's curved.
Yep. Okay, are you guys with me on this?
Absolutely.
All right, so the first part of your homework is just graphing an exponential function. All you're doing is plugging it in. As long as you plug it in correctly, you guys are in good shape. So the second part right here that we're doing is a little bit harder, but I kind of made it pretty simple for you. I think you guys will get this. It's constructing exponential functions from input-output pairs. In other words, you have coordinate pairs. So what we're going to do first on this is write our formula down, because we're going to write an exponential function. So what is the formula for an exponential function? It's f of x equals a times b raised to the exponent of x. So write that formula down. Now, does anybody remember what b is without turning that page over?
Ratio.
Yeah, it's your ratio. Good job. So I know this is my ratio, and you all know how to find your ratio, right?
Yeah.
You take your y2 divided by your, yeah. Now look, I'm going to make this a table so you can see it. So do you see that this is 3, 12, and this is 4, 24. Are you guys with me? So how do I find my ratio?
You divide
24 divided by 12. So everybody write that down. 24 divided by 12. That equals my ratio, which is 2. So that means b equals 2. Now remember, we're going to write an exponential function. So I need my b, I need my a.
Yes.
Okay?
Your a is your multiplier.
Right. But now, here's what I also have, guys. I'm going to go back to what we've been doing the last couple days because it really does fit into that. So do you agree with me that a of 3 equals 12?
Yeah.
That means my third function equals 12.
Absolutely.
So in other words, my y value equals 12. So you're writing this down. 12 equals a times, what's my ratio? B, which is 2, right guys? 2, raised to the exponent of x. Does anybody know what I'm going to replace with x? Yes, I am, right there. Because that's my third function. Do you guys understand that?
Yeah.
So x equals 3 when y equals 12. So this is 3 right here. Now we can do this actually without a calculator. So 2 to the third power is 8 times by my a equals 12. I divide by 8. And my a equals what, guys? Get 1 point what?
I kind of said that.
1.5.
Oh, I got the
So ready? Now I can write my function, my exponential function. All you have to do is write the function. You don't have to do anything else. You don't have to plug anything in at that point. We're just writing the rule. So ready? What's our rule? F of x equals, what's my multiplier, or a? 1.5 times by my b, which is 2, raised to the exponent of x, and I'm done. That's it. So your job or your goal is to get it as an exponential function. Are you guys with me?
Yeah.
Okay, this one, number 5, is a homework problem. So we're going to do this number 5 as a homework problem, and then I'm going to show you number 10 just as one more example to make sure you got it. Okay, so I want you to read number 5 real quick to yourself and see if you can identify some things here. Okay, so as you're reading through, can anybody tell me what my a of 1 is, my first day? 100. Can anybody tell me what my my ratio is? What's the ratio?
5.
Yeah, 5, because it's getting bigger. Look, it says it's multiplying by 5 the next day. Okay? So can we set up our function easily? Yeah, ready? F of x equals, what's my multiplier? 100 times 5 raised to the exponent of x. That's it. Done. It is easy. But the important thing is that you know what each letter represents. Okay? So what I want you to do now, guys, is get out your homework, and I'm going to